So let's go ahead and take a look now at box plots, or sometimes people call box and whisker plots. To create a box plot, it looks like this. What story is being told is what is the minimum value, what's the Q1, the first quartile, median, quartile 3, and then the maximum value. That's what is displayed here. We saw that in this example here. This was that bowling problem. You can see the box plot here. And what we see in the story when you choose that as your display and then look at the values, the lowest score is 98, the highest is 282. Most of in the middle is you'll see 205 is the median, but the box represents what we call the middle 50%. Remember, because this is broken up into 25%. So 50% of the bowlers scored between 142 and 262. Half of them. 25% score between 98 and 142, 25% score between 262 and 282. So there's a nice story with the distribution that's being told, and that's what we're looking at. So you'll see that sample box plot up here, right? Middle 50% of the data are inside the box, hence the box plot. This is kind of like the middle class, or that's where the average is, where almost everyone is. The middle 50%. This is where most people are. Then you have what we call those who are on the low end or on the high end. So in this problem here, you could pull out the min, the Q1, meaning just by looking at the box plot, those numbers will match up to this location here, here, and hence we call the 5-number summary is what is used for the box plot. Again, technology builds box plots. Most important for us will be the interpretation of a box plot, right? And so here are the examples of just doing one by hand, but again, rarely are we going to create any of this by hand. Here's just, again, just to show you a simple example, 14 data points. The median is the number right in the middle of all the values. Turns out to be 7 in this case, because what's the number between 6.8 and 7.2? It's 7. And then the Q1 is the middle of the first set of data. You can see that's Q2. Again, notice I'm not doing the calculations that we did over here, because with small data sets, I can see the quartiles in small data sets like this. But in the real world, data sets are large, and we use technology to do that. But again, this is just a conceptual situation so that you can understand what these values mean, what they are, so that when we have to interpret them, we can then take a look at, right, when we have to interpret them, we then can come up with a story, right? Between 2 and 9, 50% of the students scored between 2 and 9 points. What percent of students score below 9? Here's 9. This is 75% of the students, because each piece of the box plot represents 25% of the population, or the sample that we're looking at. Here are a few things to know, like if you're going to do this class, thinking about this. In class, we'll have a discussion about what do we know for sure. These are a few things that we know for sure as we go through there, right? Look at the medians, the middle, the max and mins we know. I can see the actuaries make more money than CPAs on average, right? Because of these blocks here. There's more variety in the middle, 50%. It's wider, right? The middle. There's some that make less over here, but these actuaries still make more than CPAs, even the low end, right? So there's a lot to unpack here, and we'll talk more about box plots, but box plots have become a key tool we use along with histograms to study our quantitative data.